Hi, it's harsh2029 and I am going to demonstrate my implementation of digital storage oscilloscope. First of all, I have interfaced this Cortex M4 development module with this QVGA LCD, and I am basically powering my system with this single cell lithium ion battery. So first of all, there is the battery charger. It is the BQ24091, and after that there is the TPS 73633 LDO, and after that there is the LM3224 step up DC to DC converter. So it is the so that I can generate the 5 volt from the 3.7 volt battery. There is one variable gain amplifier. It is the VCA822, so I can programmably attenuate and amplify the signal. And last one is the ADS805 analog to digital converter. But as I informed you earlier, this ADC is not working properly, so right now I have used this internal ADC provided by this Cortex M4 controller. And for demonstration purpose, I am going to show you the basic square wave generated by the 555 oscillator. So as I connect battery to the system is powered up, and it is showing the waveform from the 555 oscillator. So as I discuss the functionality, it is showing the frequency and peak volt and peak to peak voltage indication. Right now it is the square wave and it is not shifted by any DC level, so it has the same peak and peak to peak level. To change this volt per division and time per division and other things, there is simple push button interface. So as I press the selection button, first item is highlighted. It is the time per division. It is the volt per division. Right now it is the 2 volt per division. As I change it, I can go maximum to 20 volt per division. And I can go minimum up to 1 millisecond, 1 millivolt per division. So as I proceed to the next item, it is the time per division. Right now it is the 40 microsecond per division. As I change it, as I decrease it, there is the accordance changing in the waveform. As I increase it, there is also accordance change. I can go up to maximum 1 second per division, minimum up to 1 microsecond per division. Right now it is my source is the 555 oscillator, and I am changing it to the this Wien bridge simple Wien bridge oscillator. So there is you can see the sine wave indication. Right now it is some lower frequency, so I need to change the time per division. So from the frequency reading, I can say that it is the 1 kilohertz waveform, and it is the single supply Wien bridge oscillator. So it is the sine wave is basically shifted to some DC level. So it has the different peak value and different peak to peak value. As I proceed next menu item, it is the baseline shifting. Right now it is not shifted by any division. As I increase it, there is the significant vertical shifting. So basically I can shift my waveform up and down according to my necessity. Basically the purpose behind this project is to create the oscilloscope, basic functionality oscilloscope at the lower cost. As we all know, the oscilloscopes are very costly to shoot the student and hobbyist. So this is I can say my idea to implement the oscilloscope. Right now only this functionality I am able to implement, but I am also working on the input coupling, triggering level, triggering of the signal, storage of the waveform to the external memory, and cursor measurement. So that's all. Thanks for watching.